हॅलो. हॅलो.
हा सर बोला. येतोय सर आवाज तुमचा.
हॅलो.
हा सर.
हा आवाज येतोय ना सर.
येतोय सर तुमचा आवाज.
हा हा तेच तेच ना ते आता मी यांना कॉल केला टोपरे सरांना. हॅलो.
हा हा
आता ते 10 मिनिट वेळ लागेल म्हणतात. 10 मिनिट आपण थोडं वेट करूया.
चालेल चालेल सर.
हा आता हे चालू तर राहील ना.
हो चालू राहतं सर हे काय अडचण नाही.
हो 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 हो. ते आली की आपण काय आपण 10 मिनिट चालू राहू द्या. काय फरक पडतो सर ते जॉईन होईपर्यंत.
Namaste. हेलो
हॅलो.
जाधवर सर वेळ आहे का?
टोपरे सर जॉईन झाले नाहीत हो, त्यांना वेळ लागायला म्हणून थांबलोय.
असं आहे का?
हा हा
बरं बरं ठीक आहे ठीक आहे ठीक आहे
हा. पाच आता ते बंद करता येत नाही म्हणून आपण ते चालू ठेवले.
ठीक आहे ठीक आहे काय काय हरकत नाही.
हा हा हा.
जाधवर सर, मी जॉईन झालो. हॅलो.
हॅलो.
हा सर.
हा टोपरे सर, आवाज येतोय ना?
हो हो, आवाज येतोय.
हा गायकवाड सर.
येतोय आवाज येतोय. सुरू करा.
हा चालू करू ना?
ओके चालू करा.
हा ठीक आहे सर. ओके, थँक्यू. I heartily welcome all the students, resource person, principal, and my dear colleague for this special lecture series jointly organized by MSP Mandals, Arts, Commerce, Science College Killedharu, and Shikshan Maharshi, Jnandev Mohekar Mahavidyalaya, Kalam. Friends, for this lecture series, we have in the chair Honorable Vice Principal Dr. M. Gaikwad sir of this Arts, Commerce and Science College, Killedharu, and as a chief guest we have the another principal, Honorable Dr. Sunil Pawar of Jnandev Mohekar Mahavidyalaya, Kalam. Friends, we have organized this lecture for 2 days. On the first day, we have the eminent and the scholar resource person, Honorable Dr. R.J. Topre sir, Associate Professor and HOD of Physics Department of Egosiri Mahavidyalaya, Ambazogai. And his title of talk is The Theory of Relativity. And another special lecture, which is to be organized on 15th November 2022 at 11 a.m. And for that lecture, we have again the eminent and dynamic personality, Dr. Vivekanand Kaude sir of Parliam College. Now, I request our Vice Principal, Honorable Dr. M. Gaikwad sir, to give his presidential speech. Gaikwad sir.
Thank you, Dr. Jadwar sir. I am audible.
Yes. No problem, sir.
So, warm good morning to one and all. At this outset, I welcome Professor Dr. Topre sir from Egosiri College, Ambazogai. This lecture series is organized on behalf of Department of Physics, Arts, Commerce and Science College, Killedharu, and Shikshan Maharshi Jnandev Mohekar Mahavidyalaya, Kalam. So I welcome Principal Dr. Sunil Pawar sir and Head of the Department of Physics, Jnandev Mohekar Mahavidyalaya, Kalam. Friends, this is a very nice platform for these students who are joined for this lecture series, because this nice topic is organized Professor Dr. L.B. Jadwar sir, that is theory of relativity. To of this lecture series, because this theory is very, very important for your curriculum. I request Professor Dr. Topre sir to give in detail to the students about this theory of relativity. And lastly, I welcome to all these in this platform who are joined, and I request to the all the students to be continue join with this lecture series and take the benefit of this lecture series. Thank you. I am very much thankful to coordinator for giving me an opportunity to be as a president of this lecture series. So thank you once again. Over to
Thank you
Dr.
very
L.B.
much,
Jadwar,
sir.
sir.
Okay, thank you, sir. Friends, before start the today's guest lecture, I would like to introduce the today's resource person, Dr. R.J. Topre, sir. Friends, the Dr. R.J. Topre, sir, is a big dynamic personality, well known, popular among the students and in the family of the physics department. He has a very good depth of knowledge in the physics and has a fluency in the language. Dr. Aditya sir always ready to help, to support, and give the moral support to the students, and he is the best motivator to the students. Sir has a very bulk teaching experiments in the subject of physics. He has a teaching experience of 27 years, and the research experience is 17 years. The sir has published the many research papers in the international and national journals. The total research papers published is 23. Out of that 23 papers, he has published 11 papers in the international and the 6 papers in the national journals. Again, he has published one book for the UG students.
दाखवलंच ना तुम्हाला आता दाखव ते जुलै ते तू फी भरली नाही म्हणलास ना आताच कसं भेट
Dr. Arjun Topre sir has achieved the many awards. The main awards which he achieved is Bhartilal Bakkar Gold Medal for topping the list of BSc, National Merit Scholarship, second National Merit Scholarship during 1989-1991. Nominated as a EC member and Senate member by Honorable Vice Chancellor during the year 1989 and 1991. He has taken up under a project of Maha Expo 1994 and won the second prize. Thus, he recognized the research guide for the PhD from our university, Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, and the Swami Ramanand Tirth Marathwada University, Nanded. Nominated as a chairperson of the committee for framing the choice-based credit system of physics by Honorable Vice Chancellor during the academic year 2016-17. Again, the number of students pursuing PhD degree under his honorable guidance is 2. That means the 2 students are going to complete his PhD under his noble guidance. Sant Gadge Baba, Amravati University, Amravati, has performed as a referee in that university. With this biodata, I hope all the students will get well known. For this, the today's resource person, Honorable Dr. R.J. Topre, sir. I hope that today's guest lecture on the title Theory of Relativity will be certainly helpful to the students of the BSc first year, second year, third year students to upgrade their knowledge and to understand the basic concepts in the physics. The theory of relativity is the most important topic, and certainly this today's lesson will be helpful to the students in the coming examination 22nd November, that is 22nd November 2022 for the BSc second year class. With this introduction of the Dr. R.J. Topre sir, now I request Dr. R.J. Topre sir to deliver his guest lecture. Thank you, sir.
थँक यू व्हेरी मच. आवाज येतोय माझा?
हा सर, येतोय सर.
येतोय सर, येतोय.
Okay, sir. Thank you. Thank you very much for Jadhavar sir and Mohekar College, Kalam, to organize this lecture and inviting me to deliver this lecture. First of all, I am sorry for late joining because there was a program in our college and it was opened at 11 a.m. So I was engaged in that program. So I was late in joining this lecture. So may I start, sir?
Yes, sir, please, sir.
Okay, sir. So I am going to deliver the lecture on theory of relativity. It is the topic, as Jadhavar sir told, that this is the topic for the second year students, those who are ongoing examination from this 22nd of this month. So I am going to take a brief review of the topic, that is theory of relativity. This theory of relativity is made popular by the scientist known as Einstein. So the connection is such that all the people, when we say the theory of relativity, then they remember the great scientist called as Einstein and his famous equation E is equal to mc square. Now, how this equation has come? So that we want to see, and that is the basic idea of my lecture. So earlier, before Einstein, there was a popular scientist known as Newton. Newton and his mechanics, we call it as a Newtonian mechanics. So according to Newtonian mechanics, it was never expected that the space can be changed, the time can be changed, or time may be different, and mass may be different. It was never thought before. So in Newtonian mechanics, it was declared that space, time, and mass, they remain unchanged, they are invariant. And based on this, everybody has formulated their rules and regulations. Now, what was the concept of space? The space concept was such that it exists in itself without relation to anything external and remains unaffected under all circumstances. That means any circumstance can come, the space will not change. It exists in itself. There was a concept of time, and it was decided, or it was known, that by its very nature, flowing uniformly without reference to anything external. That means the time, whatever we are taking, is accurate time. There is no need, or the time cannot be changed even if space changes or something changes, right? So that was a concept of time. Another was concept of mass. We know that mass, it doesn't depend upon its velocity. Mass never depends on its velocity. The mass is an isolated system of bodies and it does not change with any processes occurring within the system. So whatever is happening in the system, mass is not going to change. So these were the concepts earlier. Now, when Einstein came, he saw that, or whatever he has observed, when he was sitting in a train on a platform, and there was some person, he was traveling in another train. So we know that if this situation occurs, or if there is a crossing of trains on a platform, then what we have to do? Suppose one train starts. We don't know whether this train is of ours or the other. So what we have to do that time? We have to see at the opposite side. So when we see at the opposite side, if the things are changing from the platform of our side, then we can say that our train is traveling. But the things which are steady from our platform, then we can say that the other train is moving, right? So it means that the things are changing when your view changes, right? So what this view means, it is known as frame of reference in terms of physics. So that is the first concept, frame of reference. So according to Einstein, there are two systems. The one in which you are standing, it is not moving, but the another one in which you are not traveling, but you are observing, that is known as the another frame. So that means there are two frames of reference. One is we draw the frame of reference in the context of coordinate system, right? So there are three axes, X, Y, and Z. There is another frame that is moving, right? So suppose this is S, this is S dash. So we can call this as X dash, Y dash, and Z dash. So the frame which is fixed, which is not moving, is called as inertial frame. And the frame which is moving is called as non-inertial frame. So it depends on in which frame you are. That means, suppose I have gone to see off somebody else on the airport and I am standing on the airport. The person to whom I am sending is sitting in the aeroplane, right? So for me, the aeroplane is a very big thing which is in front of me. Why this is because me and aeroplane both are in the same frame of reference. That is the inertial frame of reference. Now, when the plane takes off, when it goes upstairs, I feel that the aeroplane is becoming very short. Its length is becoming very short. Its mass is also becoming very small. To me only this is happening. But actually in practice, it is not happening. Whatever the mass that aeroplane has, that is same. That is not going to change. If the person is looking at me from the aeroplane, then what he will feel? He will feel that myself or me, I am reducing in size. And I will look like a dot when he will go into the space or into the clouds. Why this is happening? This is happening because the frame of references of both are different. In earlier stage, when aeroplane and me were standing in opposite direction, then we were in the same frame. But the frame is changing now. It is moving. So that if I will consider from my side, I am in the inertial frame and the person who is traveling in aeroplane, he is in the non-inertial frame. That is the frame which is moving, right? So that is the concept of frame of reference. And there are two frames, inertial and non-inertial frames. So that means when the frame is changing, definitely the coordinates are going to change. They are not going to same, right? That's why the transformation equations came, and the equations were first delivered or first given by the scientist called Galilean. So Galilean transformation equations are the first equations that were given so that we can correlate the two coordinates of the system, right? So what were the equations? Now, let us suppose that the two axes, y and z axis, they are remaining same, and the frame is traveling only along the positive x direction. If this is happening, then the Galilean transformation equations are given by x dash is equal to x minus vt, y dash is equal to y, z dash is equal to z, and t dash is equal to t. That means there are three coordinates, x, y, and z, and the another coordinate is time. So time is same, y and z component are same, but the only component that is changing is x component, and that is x dash is equal to x minus vt, where v is the velocity of the frame that is traveling, right? So these were the equations given by the Galilean, but there was a problem in this Galilean transformation equation. According to these equations, it was decided or it was proved that acceleration does not change. Acceleration is invariant under the Galilean transformation. That was the problem that we know that it is cleared after some time. So these were the, you can call it as the development in the theory of relativity, when it was known that the two frames are changing and there is something change, something is happening. Now, there was another concept earlier that is called as ether hypothesis. Ether hypothesis. It was in the mind of the scientist that Earth is covered by some material, like when sound propagates through the medium, there must be need of the medium that the light is coming towards us. So it was in the mind of the scientist that ether is surrounding the Earth, and through which the light comes to us from the sun. So that was the prediction, or that was the thinking of the scientist. Now, nobody knows whether ether is there or ether is not there. Nobody knows. So there was a need of some experiment that will prove that whether there is a medium or there is not medium. So for that, Michelson and Morley, they were the two scientists who has taken the lead to prove whether there is a medium or there is not a medium. So Michelson-Morley experiment we have learned in standard or first year in optics topic. There are two mirrors, M1 and M2, and these can be one of them, M1 mirror can be slided over on the track that is given to it, but the mirror M2 is fixed. And from this, we get the interference pattern and we get the fringes, and we can calculate the wavelength of the light. So that was the simple experiment. So what they have done, Michelson and Morley, they have carried this experiment at different places on the earth and at different times, so that the light coming from the sun can be taken as an interference pattern at different seasons and at different places. If there is something obstacle in between the light which is coming from sun to us, then there must be shift in the fringes that was expected to them. That means what happens? Suppose we are going by a car or a two-wheeler and with a speed of 80 km/h, and there is sudden speed breaker comes. What happens? Our speed decreases. Again, we cross the speed breaker and again our speed increases. So if you calculate our average speed, the average speed is less than 80 km/h. So that is general expectation. So what happens when the light is coming from the sun and suppose there is obstacle, we can call it as a speed breaker, then there must be shift in the pattern that is we are getting on the interference. So whether we are getting this, if there is the medium, we must get. If there is no medium, we must not get. That is clear. So what they have done? They have done the experiments at different places and at different seasons, so that no one can say that this is you have taken in particular summer season. So the sun is coming very fast. The rays are coming very fast, and that's why you are getting this result. So for that purpose, they have done at different season, different time, and different places. So what was the result? I am not going in detail mathematics. The result was they could not find any shift in their result. So they were expecting at least there must be a shift of 4 millimeter. So there was not shift of 4 millimeter. There was not at all any shift. Even they have performed the experiments at different places or different time. So it means that it is a negative result. That means they are expecting something, but they are not getting anything. So we call it as a negative result. So now question comes, why this has happened? But they were not bold enough to tell that there is no medium called as ether. So what will be the conclusion of the experiment? So that's why they have given different explanation of this result. And one of them has said that it is impossible to measure the speed of the earth relative to the ether. It is not possible for us to measure the speed of the earth, which is related to ether. So that was the explanation given by Michelson itself. But the only bold explanation was given by Einstein. And that's why it is called a bold statement. And Einstein said that there is no medium called as ether. There is no medium. And the light has a constant velocity. The velocity of light is a constant. It is not changing. So these are the two bold statements done by Einstein. And we call it as a special theory of relativity. And that's why in this theory of relativity, which is given by Einstein, there are some hypotheses. The one of is law of physics are all same in inertial frame. That means whatever the laws that are being given by Newton, they are eligible only in inertial frame. They are not eligible in non-inertial frame. They are only eligible in inertial frame. And the second thing he has told is velocity of light remains constant. So these are the bold statements given by Einstein, and that's why the next transformation equations, again, according to theory of Einstein, were given by Lorentz, and we came to the Lorentz transformation equation. I am not going in detail mathematics because I know that you have already learned it. I am just touching up the concepts what have been there in the theory of relativity, so that any lay person who doesn't know physics can also understand the theory of relativity. I'm just depicting the Lorentz transformation equations that were given. So according to Lorentz, x dash is equal to x minus vt divided by square root of 1 minus v square by c square. So these are the transformation equation for the coordinate x. Again, the same thing. We have suppose that the frame of reference is traveling along positive x direction and there is no change in the y and z coordinates. So that's why y dash is same and z dash is also same. But now there is a twist that time is not same. T dash is equal to t minus vx by c square divided by square root of 1 minus v square by c square. So what is this? V is nothing but velocity of the frame that is moving. C is velocity of light and others are the coordinates. T is time, x is the x coordinate, y is y coordinate and so on. So these are the two important results. And the one thing that we have to mention here, that if you modify this equation for certain, by giving certain limits, then these equations are converted to Galilean equation. That means the Galilean equations that were given earlier, they are also in resemblance with this Lorentz equation, right? Now the question comes, if the coordinate is changing, what about length? That means, how do we calculate length? Suppose this is one point, this is another point. This is point A, this is point B. What we do is, we just take the difference of the two coordinates. Suppose this is x1, this is x2. Then the length is x2 minus x1. Right? So this is the length of this object. Now, if this is changing and this is also changing according to Einstein theory, then how length can remain same? Length is also going to change. That means the length also changes according to the theory of relativity. So what is this change? How it is to be calculated? So I will just give you the formula that we have got. So L is equal to L0 into bracket 1 minus v square by c square. So L0 is nothing but the original length of the object and L is nothing but the length in the other system that you are taking. So from this you can say that L is less than L0. Whatever the length that we are looking is, we feel that it is less than the original length. That's why we feel that the length of aeroplane is changing or it is becoming shorter as it is going away from us. If its velocity is increasing, it depends on its velocity, right? So the velocity decides the length of the object. Now the length is changing. What about time? We know that time has also got some equation. So time is nothing but t is equal to, the original time is t0, 1 minus v square by c square. It means that time is greater than t0. That means we feel that the original time is less than whatever we can see. That means our time is greater than this much. So the example that is given in this theory of relativity is called twin paradox. Suppose there are twin boys, those who are those who have taken birth on the earth. And suppose one of them, we have kept it on earth, and we have taken another person on the ship, and he is moving around the earth for 1 year. Then what will happen? The age of the person who is standing on the earth will increase by 1 year. That means 365 days. But the person who is moving in the space, his age will not increase by 1 year. So he will be young than the person who is sitting on the earth. So that we call it as a twin paradox, right? So now distance is changing, that means length is changing, and time is changing. So it means that we know that length upon time or distance upon time is velocity. So how velocity will be constant? It is also changing. So that means velocity, if it is changing, then what about mass? Length is changing, time is changing. What about mass? So mass is also changing. So what is the change in mass? N is equal to m0 divided by 1 minus v square by 6. So that means mass is also changing. M is greater than m. So earlier Einstein, nobody have even thought that mass is changing or length is changing or time is changing. But Einstein has mathematically also proved that length is changing, time is changing, mass is changing. Right? Now, the famous equation, so that will be the concluding part of the lecture, that is mass energy equivalence. The famous equation given by Einstein, E is equal to mc square. This equation is a very important, has a very importance in the subject of physics, because this equation relates energy with mass. Because you know that in this equation, c is the velocity of light and it remains constant. So that means this is constant. C is constant. You cannot do anything to C. It is constant. So if there is change or increase in energy, if there is increase in energy, there must be reduction in mass, right? Because if this has to be constant, E upon M is equal to C square. If this is constant, right hand side is constant. That means if some quantity is increasing, another should decrease. Then only this will remain constant. So the other thing is the energy and mass are interconvertible. You can convert energy to mass and mass to energy. So that's why this equation has an importance, and we call it as E is equal to m into c square. So earlier there was no prediction that mass can be converted to energy. So this equation has given that mass can be converted to energy provided the velocity of light remains constant. Okay. So this is the overall syllabus that you have related to theory of relativity. I am just touching up the concepts, and I hope you have understood uh, the concept. If you have any doubts, you can ask. Jadwar sir.
Hello.
हाँ सर. कोणाला काही प्रश्न असतील तर. Hello, am I audible? If anybody has any question, I am happy to answer it.
No, sir. No one have any questions.
Okay,
Nice session, sir. Thank you.
thank you. Jadwar, sir. Mic is towards now, you.
Jadwar, sir. Hello.
I think Dadwar sir has network problem. Bhosle sir. Okay,
Okay.
I will start to vote of thanks. Okay.
Okay,
Okay.
okay, sir.
Okay. First of all, good afternoon, all of you. Good afternoon, honorable chief guest, respected principals, teachers, and my dear students. First of all, I would like to thank to principal, both principals. You give me the opportunity to speak of occupation time. It's a matter for me. On the behalf of the entire institutes, I would like to thank to honorable chief guest, Dr. Rajesh Topre sir, because the School of Program complete without of the presence and your inspiring words such as a theory of relativity. I thank to I thank you from the bottom of my heart. As also I want to express the heartful gratitude to the guests present today. Thank you all of you. The session is over, sir.
Thank you very much, sir.
Thank you, sir.
Thank you, sir. Thank you.
Thank you for giving me this opportunity once again. Thank
Sir,
you.
thank you, sir.
Leave karu?
Yes, sir. Leave it, sir.
Okay.